Well, this is an extraordinary sight to see such a full room, and a happy problem to have that we have to settle everyone down, but it is my pleasure to open up this afternoon's event. My name is Pat Gallagher. I'm the Chancellor here at the University of Pittsburgh, and we are here on the occasion of the appointment of Dr. Stephen Reis to the rank of Distinguished Service Professor of Medicine. And some of you have been at these before will have heard me say this, but it's important to sort of provide the context for this recognition and what we're doing today. The work of the University of Pittsburgh, the exceptional achievements that we are able to do here are made possible through the work of our faculty. And it's their work in advancing knowledge and increasing understanding and boosting creativity and seeking discovery and teaching and mentoring that results in all the accolades that the university enjoys. And our faculty set a high bar. We expect every faculty member to play their part, and they do. But even among this remarkable group of faculty, there are a few scholars who simply stand out above the rest. Not only do they discover, but they challenge the way we think about a problem. They are catalysts for change. They are at the frontiers of knowledge. They are the ones behind the true paradigm shifts in our understanding. And we choose to honor these individuals who rise well beyond the knowledge, stature, and service of full professor with a special designation, and that is appointment to the distinguished ranks. This is the highest recognition that our university can bestow on a faculty member. And today I am proud to celebrate you, Steve, as you join this exceptional group of scholars. Now, Steve is a beloved doctor and cardiologist, and I can say this, he has one of the highest patient satisfaction scores. I know because my dad's one of those patient satisfaction scores. Steve and his team, I think it's not an exaggeration, saved my father's life and came here dealing with very serious heart issues. So I say this not only as a colleague, but as a friend and a great admirer of your work. But in addition to that excellence as a clinician and that patient care, he is also an extraordinarily accomplished researcher. A quick search on PubMed pulled up more than 150 published articles to his name, and his titles, as you imagine, include many here at the university, including Associate Vice Chancellor for Clinical Research and Professor of Medicine and Emergency Medicine. He is also the founding director of the Clinical and Translational Science Institute, which he has helped build critical bridges between innovative research approaches and real-world health practices and policies. And another new title for Steve that carries in addition to the one we celebrate today is Director and Principal Investigator of PA Cares, which is a Pitt UPMC initiative fueled by $50 million dollars of federal funding that aims to advance the field of personalized medicine and disease prevention. These achievements show that Steve is an innovator, a healer, a visionary, and investigator. And with these remarkable achievements on record, it's easy to see why Art, as well as Steve's colleagues and peers, have recommended him for this appointment. It is our custom in the Academy to present a medallion to those who are propelling their disciplines forward and have made these exceptional scholarly contributions to their field. Of course, the medallion is part of an age-old tradition that reflects the high esteem in which we hold our colleague. And so without further delay, I'd like to ask Art Levine to join me in presenting a medallion to Steve as we officially recognize his rank to Distinguished Service Professor of Medicine. Steve, congratulations.
Thank you, Pat. Today, I'm equally delighted to celebrate the appointment of Dr. Reese as Distinguished Service Professor of Medicine. In addition to this most prestigious position, Steve is Associate Vice Chancellor for Clinical Research in the Health Sciences, and as you heard, the founding director of our Clinical and Translational Science Institute. Steve received the baccalaureate degree in biology from the Massachusetts Institute of Technology and his medical degree from Harvard Medical School. He completed an internship and the residency in medicine at the Brigham and Women's Hospital and the cardiology fellowship at Johns Hopkins. Steve joined our cardiology division in the Department of Medicine in 1994, and clearly he's risen rapidly to the academic ranks. In 2006, Steve was at the helm of our successful application for a Clinical and Translational Science Award from the National Institutes of Health. Pitt was among the first 12 institutions in the nation to earn one of these transformational grants, which created our Clinical and Translational Science Institute with Steve as its founding director. Since then, the Institute has twice received 5-year renewal grants. The most recent was in 2016, and its funding from the NIH has totaled more than $221 million. Under Steve's leadership, the CTSI has worked tirelessly to speed new treatments to the people who most need them. The Institute provides the support necessary to bridge the gap between innovative research and effective clinical and public health practice, health policy, and community engagement in research. Most recently, also as you've heard, the CTSI and UPMC launched the PA Cares for Us research program. This research participant enrollment effort is part of the national drive to enroll 1 million research participants in the Million Human Genome Project. This will revolutionize our understanding of how environment, genetics, and individual behavior affect our health. The CTSI aims to enroll 150,000 participants in the region over the next several years and anticipates receiving more than $50 million from the NIH for this project. I wouldn't bet against them achieving those goals, as they seem now to be setting the standard. They enrolled the first volunteer research participant in the nation on May 31st. With more than 1,300 signed up as of today, they are responsible in Pittsburgh for 40% of the enrollment in the nation to date. In his own research, Dr. Reis has explored many facets of cardiovascular health and heart disease. And in 2005, he was elected to the prestigious American Society for Clinical Investigation, the Young Turks. Please join me now in welcoming Dr. Stephen Reis, who will present his talk entitled Inspiration and Innovation, Translating Life's Lessons into High-Impact Research. Steve.
Thank you, Dr. Levine, Chancellor Gallagher. Thank you for your kind words, and thank you for this great honor. And thank you all for coming here today. When I was first asked to give this talk, I initially thought I would just present my research over the last 20 years. But then I decided to step back and look at the big picture. And the big picture today is all about service. So today, what I decided to talk to you about is 8 life lessons, 8 lessons that I have learned in my professional career, and describe to you how these lessons have influenced my approach to both service and research. And I'm hoping that there are some junior investigators here today who may embrace some of these lessons and perhaps consider incorporating them into your own work. So I'm going to start with a roadmap. And this is a roadmap to my life. This is a roadmap of my life lessons, but it's also an outline of my talk today. So here we go. So I grew up in New York City. And in New York, I learned the value of storytelling. I also began understanding what mentorship was all about. And from there, as Dr. Levine had mentioned, I moved to Boston for college and medical school and residency. And in Boston, I learned how to learn from others. And I started to understand the value of research mentorship. And as an aside, the best thing that happened to me in Boston is I met and married my medical school classmate, Evelyn, who I know many of you know. She's in the Department of Pediatrics here. And after we finished our residency, we decided we wanted to complete our training at Hopkins. So we packed up and moved to Baltimore. And in Baltimore at Hopkins, I learned a deeper level of mentorship. And from there, I took my first faculty position here at the University of Pittsburgh. And the lessons that I learned here, which I'll present to you today, are career mentorship, how to think big and do it, the value of teamwork and networking, how to follow my passion, and how to step back and see the big picture. So this is what I'm going to talk about today. And I'm going to start with lesson number 1, storytelling. So I grew up in New York City, and at the end of high school and through all of my vacations through college and medical school, I worked as a photographer for a newspaper. My photography partner and best friend, who's here today, is John Cassessa. John taught me many things, and one of the great things that John taught me was storytelling. He taught me that every picture we took needed to tell a story, especially in the newspaper, because people don't always read the caption. So the picture had to stand by itself and tell a story. And we were privileged. We were privileged to meet people from all walks of life. And everyone wanted to tell us their story because everyone wanted their story in the newspaper. And when I say all walks of life, I mean all walks of life. So John took these pictures. So a picture of President Carter and Ronald Reagan. And if you look for this story, you can see the campaign poster. This is when Reagan came through New York campaigning during his presidential candidacy. And we saw the best sides of humanity. So I took this picture at what they call a baby parade, where in the neighborhood, they dressed up babies in costumes and put them on floats and paraded them through a neighborhood. It brought joy to a neighborhood that was very financially distressed, and you can see the abandoned warehouse in the background. We also saw the not-so-good side of humanity. I took this picture at a shooting. We were actually called as witnesses to this police-involved shooting, and we witnessed tragedies of all kinds. I took this picture from the shore by the runway at Logan International Airport. So it was all about storytelling. And you'll see later on today in my talk why storytelling is very important to what we do today in biomedical research. We also met first responders from all across New York City, police and fire and EMS, and also the local volunteer fire department. And people don't realize that there are about a dozen local volunteer fire departments in New York City. And I was so impressed by the selflessness of the volunteers in that department that I joined. I became a volunteer firefighter, which leads me to lesson number 2, mentorship. This is my crew from the 1980s. We had just fought a big brush fire, and this is us. I'm over here. And to my right is Archie Kenneman. Archie was our deputy chief. He was our mentor. Archie taught us how to save lives long before I even thought about going to medical school. And as a team, we saved lives in all kinds of ways. Archie trained us. We trained and trained and trained relentlessly. And as an aside, I'm going to pause here for the junior investigators in the audience. Talk about training very quickly, because in research, when I started out, all you needed to do was one really good research study and have one high-impact publication, and then you can hang up your shingle as a clinical researcher and get a good faculty position. No more. The methodology is so much more complex that junior investigators, you should think about this. You need training, and I refer everyone to the Institute for Clinical Research Education under Wishwa Kapoor and Doris Rubio, because I know we have training programs for everyone. But back to my story, we trained relentlessly. We trained to be prepared for the expected, like carrying someone out of a burning building. And we trained to be prepared for the unexpected. This picture was sent to me by my close friend, my old fire captain, Mitch Udowich. 5 of the men in the pictures I just showed you responded to the World Trade Center after the first plane struck. And I learned many lessons from those men over their lifetimes. So I knew all about mentorship when, as a resident, I decided I wanted to pursue a career in research. So I looked for the right mentor, and I found that right mentor in Sam Goldhaber at the Brigham. And Sam was a world-renowned expert in venous thromboembolic disease. And what he taught me is that early on in your career, you should recruit, enroll, and conduct study procedures yourself. He taught me if you don't recruit and enroll patients yourself into your study, you really won't understand the complexity of your study and the feasibility of your study. And he explained to me, if you do not do the study procedures yourself, you won't gain empathy for your research participants. He reminded me that those participants were volunteers who were doing study procedures that will benefit us, benefit our science and our careers. And you really need to understand their motivation and gain empathy. So I learned that from Sam. And then when I moved to Baltimore, to Hopkins, my mentor was Gary Gerstenblith, who really launched my career. And what he taught me is forget about constraints. Design the ideal study and make it happen. And I'm going to give you an example. When I trained in the 90s as a cardiology fellow, this was the face of heart disease. Everyone thought that heart disease was a man's disease. No one talked about the fact that women get heart disease too. And there wasn't much research done in heart disease in women. And Gary said to me, we should really study heart disease in women. And I'm going to show you a couple of experiments that we did. We enrolled women who went to cardiac catheterization because they had chest pain. So they went to the cath lab on clinical grounds. And we found women who had normal arteries. And what we did is we measured the blood flow in those arteries and gave these women a single dose of intravenous estrogen, ethinylestradiol. And we found that in 15 minutes, the blood flow down their arteries went up on average 23%, significantly more than when we gave placebo. And the reason why is that estrogen dilated the small vessels, the microvessels of the heart that you can't see when you squirt dye in the arteries. And by dilating the small arteries, you decrease coronary vascular resistance, which causes increased blood flow. So estrogen increases blood flow to the heart. But we did more. We stimulated those arteries. We gave a drug called acetylcholine. So the arteries, some of you know, the arteries are lined by endothelial cells. And when they're healthy and stimulated by a drug like acetylcholine or other stressors, they release nitric oxide and the vessel gets bigger. So healthy arteries, when stimulated, get bigger. When the arteries are diseased, the endothelial cells are diseased, the earliest signs of atherosclerosis, when you stimulate it with a drug like acetylcholine, they paradoxically constrict. So abnormal arteries get smaller. And what we did is we found a group of women who, when we stimulated their arteries with acetylcholine, the arteries constricted, their cross-sectional area went down. We gave them one dose of estrogen, and in 15 minutes, we were able to abolish that response, and this is different than placebo. So the bottom line is estrogen was good for the heart, right? We dilated the arteries, we increased blood flow, we improved their arterial endothelial function. So that was great. My whole career was set. I was going to go down that path, but then the truth came out. 2002, Time magazine said it all. There were 2 large-scale, randomized, placebo-controlled clinical trials of hormone replacement therapy in postmenopausal women. And guess what? When you gave women hormones after menopause, you didn't decrease the risk of cardiovascular disease. In fact, some women, you actually wound up with an increase in cardiovascular disease. And this literature is actually evolving, and there's actually more recent data that came out in the last month. But the bottom line is I was at a crossroads in my career here, because in the lab, estrogen is good for the heart, and in clinical trials, estrogen not so good for the heart. So I needed to make a decision in my career. Do I go down the path of basic biomedical discovery and spend the rest of my career looking at the cellular and molecular mechanisms of estrogen's effect on arteries? Or do I go down the path of problem solving? Why are women's hearts different than men's hearts? So I started going down the problem-solving route. I then moved to Pittsburgh, and my mentor here was Art Feldman, who recruited me. He was the chief of cardiology here in 1994. And Art taught me many lessons, but the 2 I want to highlight. 1, do thematic research. He taught me, don't be opportunistic and write a lot of papers because people are handing you data sets. He said, focus on the theme. He said, when you go to a national meeting, you want people pointing to you and say, he's an expert in X, whatever X is. You want to be an expert in something. And he also told me, when you write a grant, build a straw man. When you write a grant, build a straw man. I had no idea what he was talking about when he said, build a straw man. So I slept on it. And after a couple of days, I realized that's what my friend John taught me in the newspaper business. Build a straw man is telling a story. When you write a grant, you have to tell a story. So right before we moved to Pittsburgh, I was finishing my fellowship. Art sent me an RFA for a grant called Evaluation of Ischemic Heart Disease in Women. I had never written a grant before. I had no idea. I took some plain paper and I wrote the grant, and I figured, all right, I'm going to just tell a story. So what I did is, very simply, what's the foundation? What's in the literature? What do we know? I wrote that we know that women have a lower risk of heart disease. When they do get heart disease, they present 10 years older than men. They have less fat in their arteries, less atherosclerosis, and estrogen seems to be protective in premenopausal women. That's what we know. What did we contribute to the literature? Well, we were the first in the world to show that estrogen improves flow down the coronary arteries, Estrogen improves endothelial function and improves vasomotor tone, the tone of those small arteries. Therefore, given all of that, our question was, what's the effect of this vasomotor tone on chest pain in women and cardiovascular risk? So it's a really simple story. And I'm showing this because I review a lot of grants every month and every year. And what I find is about 2/3 of the grants I review don't tell a story. 1/3 of them do. Guess which ones tend to get funded? You really have to build that straw man, in this case the straw woman, and tell a story when you write a grant. So I wrote this grant at the end of my fellowship, and we got it. It was the first grant I wrote, first grant I got. It was a few $1,000,000. It was a U grant, so there were four centers here, and we enrolled 936 women with chest pain who went to the cath lab to look for blockages in their arteries. And the goal of the entire study was to improve diagnostic testing for women with chest pain. But each site was allowed to have their own goal. And my approach tends to be, let's look at the extremes, because if you understand the extremes and the mechanisms, you have a better understanding for everyone in the middle. So the bottom line is what I looked at. I was really interested in women with chest pain who went to the cath lab who had no blockages in their arteries. And back then, when that happened, they were told, this is great news. Your heart's fine. You must see your gastroenterologist because it has to be reflux, or see your internist because it's musculoskeletal pain, but your heart's fine. So we took those women and we put a wire in their arteries, and on the tip of the wire was an ultrasound transducer. And we could look at the velocity of blood flow every time the heart beat. And we gave a drug called adenosine. And what adenosine does is it dilates those small arteries, those microvessels that you can't see in the heart. And when the small vessels dilate, you maximally increase blood flow. So in a normal heart, when you stimulate it with adenosine, the flow velocity, or even the flow in the artery, goes up more than 2.5 times. In this normal case, 3.3-fold. And if a woman or anyone has microvascular dysfunction, those small arteries are abnormal, flow goes up less than 2.5 times, in this case 2.2. And what we found is we looked at all these women with so-called normal arteries and found that 53% of those normal women did not have normal hearts. 53% of those women had abnormal small vessels. And that's really important because one of my colleagues in the WISE study, Carl Papin, a very prominent cardiologist at the University of Florida, followed women in the WISE study who had abnormal microvascular function and found out that they had about a 35% risk of dying, have a non-fatal heart attack, a stroke, or an admission to the hospital for congestive heart failure in 6 years, compared to the women who had normal function. So here we have it, right? Half of the women who were so-called normal, who had chest pain, were not normal. They had abnormal small vessel disease, and they had a significantly increased risk of events. Now, given all that, I will tell you in 2017, when a woman goes to the cath lab today with chest pain and has no blockages in the artery, you know what happens? She's told, good news, your heart's normal, go see the gastroenterologist or the internist. It is not the standard of care to put that wire in the artery and assess the small vessels. And what this taught me is translation of research into clinical practice is really hard, right? So then, based on this, I thought I needed to redouble our efforts here at the university to help investigators move their research across the translational research spectrum, which brings me to lesson number 3. Many of you know Lauren Roth, who's here today. I've learned many lessons from Lauren Roth, but years ago when he was the chief medical officer of UPMC, he pulled me aside one day and he said, Steve, you need to adopt UPMC's unofficial motto. Think big and do it. And he said, Steve, if you don't think big, you will never accomplish anything big. And if you think big and don't do it, no one's going to take you seriously. So I embraced that back then, and I embrace that every day when I get to the office. Think big and do it. Which brings me to the CTSI that Dr. Levine and Chancellor Gallagher talked about, the Clinical and Translational Science Institute. I founded this in 2006 with a lot of help from our colleagues. I see the CTSI as an umbrella organization. We have many projects, but we have 3 big funding mechanisms. One is, and I'm going to talk about each one of these 3. One is the Clinical and Translational Science Award between 2006 and 2021. As Dr. Levine mentioned, $221 million in grant funding. I'm going to talk about the Accrual to Clinical Trials project. $25 million over 5 years. And the precision medicine initiative that you heard about earlier, we found out late last night that this is going to go up by another $14.7 million. So we are operating with over $300 million of research funding. So we can think big and do it. CTSI, I know many of you know about it because I see familiar faces here. CTSI is an infrastructure program. We have resources, facilities, expertise to support all kinds of research to help move that research across the translational spectrum into practice. And just very, very briefly, just some of the things we do. We work with the Department of Biomedical Informatics. We're building our new research data warehouse, so soon it'll be easier to pull electronic health record data for research purposes. Community engagement, we're engaged with more than 150 community organizations. We have lots of education and training programs through the Institute for Clinical Research Education, including K and T awards. We've given out more than $10 million in pilot funding. We support statistics and regulatory components of studies for investigators. We have 11 research facilities and practice-based research networks. We have innovation core. We have a biomedical modeling core. We recruit patients into clinical trials. We do all kinds of stuff. And just to show you some numbers, over 11 years, we have trained through the Institute for Clinical Research Education almost 1,500 scientists. We have supported the work of nearly 2,600 investigators who have conducted almost 5,000 studies. And when investigators cite our grant as a funding source, which is probably about half of the investigators we help, their literature has been cited almost 90,000 times in the medical literature. And when we looked at Pitt's entire NIH portfolio, we've helped more than 25% of the studies in Pitt's NIH portfolio. So we're thinking big and we're doing it. The reason why we're doing it is because of teamwork. Lesson number 4. So nothing speaks to teamwork more than firefighting. So I was a firefighter here outside of Pittsburgh for about 15 years. And I'll go back to what my old friend, my old deputy chief, Archie Kenneman, taught me as a firefighter when he trained me. When you're a firefighter, you go into that fire as a team, and you absolutely come out of that fire as a team. You don't come out alone. It's all about teamwork. And teamwork is what makes CTSI work. So this is my executive group here. Dave Mathias, Executive Director of Finances. Margaret Palumbo, who's our Executive Director of our PA Cares for Us Precision Medicine Initiative. Laurel Yasko, Executive Director of Operations. And not pictured here is Lisa Palevsky, who keeps us all organized and makes sure we get our jobs done. And this team, they go way beyond their job descriptions. I will tell you, they are some of the best strategic thinkers we have here at the University of Pittsburgh. They can do anything. And they can do anything because of our entire team. This is our CTSI and PA Cares team. Now, since we took this picture, we've hired 11 more people, and we're hiring another 11 people. And this team actually can get the job done. And just as an aside, if you haven't seen our tractor trailer truck, next time it's on campus, knock on the door and go inside. We have 23 working lab stations inside, and we go out to public schools throughout the region. We teach middle and high school students the scientific method with hands-on experiments. Over the last 8 years, we've engaged more than 70,000 middle and high school students, and some of those students will be sitting in these seats someday. They're our future. Now, the reason why CTSI works, this is my approach to teamwork. Everyone on my team embraces a shared mission, and that shared mission focuses on service to the university. Everyone's contributions are valued. My favorite part is that the entire team ideates about new initiatives. So we meet as a group, the room is packed once a month, and I usually throw out a crazy idea. And everyone, it doesn't matter what the job description is, everyone presents their ideas on how we achieve this initiative. I also encourage people to learn from their non-medical friends. I tell them when they're at a soccer game, when their son or daughter is playing soccer, talk to the other parents, find out what they do for a living. When they're at a party, find out what people do for a living, and think about what are they doing? How does that apply to what we're doing? Learn from others outside of our field. And that encourages creativity and what they always call crazy ideas. And just as important as teamwork is networking. So I'm going to show you a real-life networking story right here. This is a picture of the neighborhood where I grew up in New York City after Hurricane Sandy. Part of the neighborhood was totally destroyed. The fire department I grew up in Water came up halfway up the fire trucks. My friend Mitch Udowich, who sent me that picture of the World Trade Center, I'm sitting in clinic on a Thursday, and he calls me up and says, Steve, we're closing down the fire department. 2 fire trucks, 3 ambulances, totally destroyed. The guys are out doing rescues on a rowboat. And I said, well, you can't close down the fire department. It's like 84 years old. It's part of the neighborhood. We protect the neighborhood. So I'm thinking, how can we help them keep the fire department open? So I only know one person who can help, and that's my friend, Bob Full. Now, Bob at the time was deputy director of the Pennsylvania Emergency Management Agency. No one cares about public safety more than Bob Full in my book. He's one of my heroes. And I email Bob Full, and Bob emails Pennsylvania Fire Commissioner Ed Mann. Now, about an hour later, Rick Lohr, who's the head of Somerset County Emergency Management, he emails Commissioner Mann because there's a fire truck in Somerset County in Little Hooversville, Pennsylvania, a fire truck that was a surplus fire truck. And Rick says, is there anyone back east who can use a fire truck? He emails the commissioner, who emails Deputy Director Full, who emails me. I call my friend Mitch. 2 days later, firefighters from New York City are in Hooversville, population 600, picking up a fire truck. But that community came together. That fire truck was not just packed with hose and fittings and couplings. It was packed with clothing, with food, with water, and they handed over a wad of cash for back east. The whole community came together. But here's the best part of the story. So my friends in New York City were at the World Trade Center on 9/11. That fire truck was the 3rd fire truck to arrive here when United Airlines Flight 93 crashed in Shanksville, Pennsylvania. So that fire truck that responded to the crash in Somerset was being used by firefighters in New York City who responded to the World Trade Center. That's a good story. This is how networking works in my job. So I'm fortunate to be a CTS API. There are 60 other CTS APIs across the largest medical institutions in this country. They can do absolutely anything at their institutions. If I need something done in another institution, it's one phone call or one email. And when we start working together, we can do great things. So I'm going to highlight one project called NIH Accrual to Clinical Trials. And I'm leading this project with my colleagues. Lee Nadler is here today. He's from Harvard. Bob Toto's here today from UT Southwestern, and Gary Firestein from UC San Diego. We put together this project called Accrual to Clinical Trials. And the way it works is we link together the electronic health records now at 20 institutions, in 6 months, 34 institutions, and in a year and a half, more than 50 institutions. The EHRs are linked together. In these 20 institutions, there are 40 million patients with electronic health records that are linked. And the initial goal is cohort discovery. So when I flip the switch and announce this in December, you as investigators can sit at your desktop or laptop and type in the inclusion and exclusion criteria for your clinical trial, your multi-center study. And within seconds to minutes, you will get counts back saying how many patients meet these criteria at all of these institutions. So that's great for study design. That's great for study feasibility. That's great when you write a grant and you need to prove to NIH that there are patients who meet your inclusion criteria for your study. But there's more, because this is our vision. How do you actually recruit those patients across the country into your study while you're sitting at your desktop in Pittsburgh? So here's what we're going to do. Within 1 to 2 years, this will be live. You'll be able to be sitting there at your desktop and put in your inclusion and exclusion criteria and query the electronic health record at all of these institutions and reach out to colleagues automatically at these institutions who can then engage the patients. And this is incorporating a very complicated regulatory and governance framework into the informatics structure. But this is the vision, and this is going to be a game changer in the national clinical trial landscape. Okay, a few more lessons. Lesson number 6, one of my favorites, learn from others. I took this picture from my college yearbook in 1982. Pat's laughing because he knows who this is. This is my friend, Wes Bush, and my other friend, Joe Mayo. This is actually a computer. 1982, they built a computer for their junior capstone project, and this is what a computer looked like in 1982. And Wes, like many of my college friends, some of whom are here today, are very accomplished engineers. And Wes told me as recently as a couple months ago when we had dinner, he said he knows nothing about biology. But yet we were sitting over a pizza one day, and he said to me, "What are you doing in biology lab?" And I said, well, I'm growing these cells. These cells have a charge on the membrane, and they're attached to this bead that has an opposite charge, and we can grow them in culture. But the problem is we have difficulty pulling the cells off the beads to actually run the experiment. So he said, Steve, give me a piece of paper and a pen. And he drew this out for me. This is an electrical engineer. He said, so you have a flask, and you have these beads with a charge, and you have these cells with an opposite charge, and you have a bunch of them that spin around in culture, right? He said, well, why don't you just make another field with an opposite charge that's outside the flask and just pull the cells off of the beads? So I remember that night in 1982, because that's the night I realized I needed to learn from others who are outside what we do, outside of our biomedical field. This is how I learned from others. About 5 years ago, my son John, who's an engineer, said to me, hey, Dad, engineers solve problems. Engineers solve problems. So think about it. As scientists, we don't necessarily solve problems, right? Many scientists do scientific discovery, which is critically important because without the discovery, you can't solve problems. But it's a very different way to approach things, right? So 5 years ago, I decided in CTSI, we want to identify a small cadre of investigators here at the university who really want to solve problems. And how do we stimulate their work? How do we support their work? And how do we develop a community of problem solvers, of innovators, and slowly change the culture? This is about 5 years ago. So what I did is I reached out to a friend outside of our industry. So one of my college and medical school classmates, Peter Diamandis, founded and runs X Prize. And if you haven't heard about X Prize, it's an incentive prize competition, and they say they do this to solve bold, audacious problems. And the first X Prize, Peter gave out $10 million to the first team that can build a spaceship that can launch into space twice in 2 weeks, $10 million prize. This is Spaceship One. They won the prize. That contest launched a whole new industry of civilian spaceflight. So I emailed him and I said, how do you do this in academia to get scientists to solve problems? And he led me to some of his executives, and we hired 2 of his former X Prize executives as consultants, and they helped us build the PIT Innovation Challenge, PINCH, that some of you have heard about. With PINCH, what we do, it's a contest. So our current contest that's ongoing, we give a broad topic. Our current one is wearables. How do you actually use wearables to improve health? And teams can submit their ideas in a 2-minute video, which they don't realize at the time is a lot harder than writing a 15-page NIH proposal. But in 2 minutes, they have to tell us what the problem is they're trying to solve, how they're going to solve it, and who their team is, who are their team members. They go through this process, and we whittle it down, and at the end, there are several teams that compete in a Shark Tank-like environment. We have one coming up in a few weeks. We'll have about 6 teams or so in front of a few judges. There are usually 150 people in the audience, and they pitch their project, and they can win anywhere from $25,000 to $100,000. And let me just show you a couple of winners that we had, just to give you an example of how scientists here can solve problems. This was one of our first winners, the Oxyden team. They won $100,000 in 2015. They developed a biomaterial with anti-inflammatory, antibacterial properties, and what they pitched to us, they wanted to coat this on dental implants to prevent rejection. We loved it. They got funded $100,000. Turns out if you paint this on the side of a ship, the barnacles don't attach. So they pivoted, right? They licensed this, so now it's being used on ships, so the barnacles aren't attaching, right? So what I understand is that this team's going to use the money from the licensing to go back into the biomedical arena. But to me, that's a great success story. And one of my favorite teams won $25,000 last year, Aeronics, a team of 4 engineering students in our School of Engineering. They developed a new way to provide supplemental oxygen to patients that fit in the palm of your hand. And this is really important because last week I had a patient in the office who came in with oxygen, and I was trying to get her on the table, and I almost tipped over her canister of liquid oxygen, and she yelled at me and said, you can't do that, because if you do that, it's going to shut down. So think about it, if you can have something that's in the palm of your hand. So we funded this team, they're moving forward. They were selected as one of the nation's best university startups. They are now in New York. They received $150,000 as part of an accelerator in New York, and they're moving forward, and I'm hoping in a few years I'll be prescribing this to my patients. Let me show you some numbers. In our contests that we've run in the last 4 or 5 years, We've got 434 applications by 1,470 innovators. Only a third of those innovators are on our faculty. That means we've engaged students and trainees and postdocs and community members and industry partners. We invested, CTSI, I put in $2.6 million into these projects. In the last couple of years, these projects have raised more than $3 million, so we essentially doubled our investment, right? 57 of these projects are being translated into practice through the commercialization pathway. So I'm really proud of my pinch team here that put this program together. I also learned from my family. My son David, who's here today. So David is a student in the School of Architecture at the University of Virginia in Charlottesville. And I went to parent freshman orientation when he started. And the dean stood up in front of the room, and I was in the back row with a cup of coffee like I usually am, and the dean stood up and said, parents, 91 of your students are entering this class of architecture, and only 45 of them will have jobs as architects when they come out. And I woke up, and she said, she paused, it was a very dramatic pause, and she put up her hands and said, don't worry, parents, the rest of your students will have jobs because we teach the theory of design thinking. And she started talking about this, and I was listening closely. Design thinking, human-centered design. Gain empathy for your customer. Really help them deeply define their problem. Ideate with them. Prototype solutions rapidly. Test them, and it's a very iterative process. And I'm sitting there, and I'm thinking, why don't we do this in science? Right? We should do this in science. So I did what every good academic would do. I came home and I bought a book about design thinking. And I read a book, and it turns out you can't learn design thinking by reading a book. So what I did, with Dave Mathias and Laurel Yaska, we decided we were going to hire 2 companies that do human-centered design and give them projects to do. And not only were we going to get something out of those projects, but we were going to carefully study the design thinking process, so we had a deep understanding of what that was about. So I'm going to highlight Wondros. Wondros was founded by Jesse Dillon, who's here today, with his colleague Patrick McGovern, and some of their own other colleagues are here. We challenged them. We said, how do you recruit more participants into research studies? Run the design thinking process for us. This is what they did. They interviewed dozens and dozens of people who were in research studies, people who refused to be in research studies, people who didn't even know what research was, doctors, nurses, researchers, coordinators. They took their information and synthesized it and developed these personas. So Jacob Allen is not a real 22-year-old man. This is a composite of data that they collected from their interviews in people who are 20 to 30 years old. You know, what are their life experiences? You know, what are their goals? He's a new college graduate who wants extra money. You know, he did studies for beer money in college. You know, what appeals to this person compared to these other people? And then what they did is they deconstructed the research process. And I don't expect you to be able to read this, but how do researchers here at the university actually engage people in their studies? And what they did is they took each one of their personas and see how they interacted. So for instance, the 22-year-old man is not likely, he's not going to learn about research studies from his doctor. Because how many 22-year-olds go to the doctor regularly? But he may learn about research studies on his iPhone. And each of these personas learn differently. And what we found when we did this exercise is here at the university, we had a major hole in our portfolio. And that is, we did not do a good job using digital messaging and digital media. So Wondros developed a whole digital messaging strategy. It's a multimedia campaign. I'm just going to show you one thing that they did for us. First of all, they helped us coin this campaign, name this campaign Pitt Plus Me, already very engaging. But I'm going to show you an example of the website that we launched. And as you can see, this is not a traditional academic website, but it incorporates many of the things they found in their interview process. So this is our website. What are we doing? We're trying to improve health through research. We're highlighting our research participant registry. We now have 134,000 people who have signed consent, who are allowing us to match research studies with their information and push studies out to them. We have 225 studies in the registry right now. Here are some motivations. You know, what's Pitt Plus Me about? You know, do this for the next generation. I'm doing this for my grandchildren. And you can actually go online and search for studies. So you can click here. You can actually say, I'm interested in some studies for me. hit next. Put in a little bit of demographic information if you want, so we can try to start matching studies online. And once you put this information in, you hit next, and you can pick what kinds of studies you're looking for. So here, I'm interested in precision medicine. I want to see precision medicine studies. You hit search, it'll give you the studies that we have in our registry in precision medicine, and each study has its own website. So this is our PA Cares for Us study, which happens to have a video. It tells you eligibility criteria, what the procedures are. And I'll tell you, we've had more than 50,000 calls from people to enroll in our studies based on this campaign. So this is all design thinking in practice. So here's my vision. So I'm building a Center for Translational Design, although we'll probably change the name a little bit. But I want to find a cadre of investigators who will embrace the whole concept of human-centered design. We're going to provide training opportunities for them in design thinking. We're going to provide interactions with designers, and I'm putting pilot funding in there so that they can incorporate design into their projects. So look out for this. This is coming soon. This is my favorite lesson. 2 more lessons. My favorite lesson. Follow your passion. And I'm going to highlight one of my colleagues, Dave Hostler. Dave was in our faculty in the Department of Emergency Medicine before he moved on to be a department chair at SUNY Buffalo. And I was introduced to Dave because he's a firefighter. But he also did researcher in firefighter health. And he told me something I didn't know, that firefighters probably have one of the highest rates of cardiovascular disease, not just when they're fighting a fire or the day after a fire, but even after they retire. But no one knows why. What's the reason? So I met Dave and I walked into his lab, and he had a great study going on. He had firefighters in full gear with a mask and a pack on a treadmill until they couldn't exercise any longer, and he cranked up the heat, made it a hot room to see the effect of heat exposure. And afterwards, I said, Dave, that's an awesome study. But why don't we do the ideal study? Why don't we study firefighters while they're fighting a fire? And he said, well, that's a great idea. How do we do that? So there's only one person I know who could do that. I called my friend Bob Folt, who linked me to the Allegheny County Fire Academy. This is the set of experiments that we did. We went to the Fire Academy and studied firefighters who volunteered to be research participants before, during, and after they fought fires. Here's a research participant. If anyone wants to be in one of Dave's studies, you can raise your hand now. We studied many things. The first thing that Dave studied was rehab. So when a firefighter is in a fire, within 10 minutes, his or her core body temperature goes up to over 104 degrees. They're pouring out sweat. You can actually see sweat accumulating in their boots. And when they get out of the fire, they're rehabbed. So the typical standard operating procedure is toss them a bottle of water. And if you're lucky, there's an air-conditioned PAT bus you can sit in. That's the standard. So Dave decided he was going to test different rehab regimens, such as putting vests on and pumping ice water through, things like that. We tested statins. We tested the effects of aspirin. We did all kinds of testing of these firefighters in cardiovascular physiology. And Dave, I will tell you, is one of my most favorite investigators. And you know why? Because Dave followed his passion. He designed the ideal study. He actually conducted the study. Every time a firefighter went into that building, Dave went in with him or her to not just do the protocol, but to make sure that they were safe. He built an excellent team around him in the Department of Emergency Medicine. He mentored junior investigators. I don't know how many of Reese lessons he did, but no one should be surprised that his research is translated into practice, that there are fire departments around this country that have changed how they rehab firefighters when they come out of a fire. And I think it's possible that Dave's work may save the lives of one of my old friends. Now, just as an aside, I helped Dave and his team with some experiments. And my job in one of the experiments was to actually take the wooden pallet and throw it on the fire. And when I ran out of air and I came out of the building, Dave told me that the temperature in that room was just about 1,500 degrees at the ceiling. And when I took my helmet off, part of it was melted. It was the best day of work I ever had in my career. I would do that again in a second. Last lesson from Dr. Levine. Dr. Levine is my career mentor. Dr. Levine has taught me many, many lessons, and I'm only going to share one of them with you today. Dr. Levine taught me that you need to step back and see the big picture. So I'm going to show you a big picture. Here's a big picture guy. President Obama. This is when he came to Pittsburgh. The chancellor invited him. He was at the Frontiers Conference last year. In his 2015 State of the Union address, President Obama announced he wanted to change the way we all practice medicine. He wanted medicine to be precision medicine. And he secured money from Congress. And actually, the money from the current Congress is even stronger. There's stronger support now than there was a couple of years ago. And what he did is he supported the All of Us Precision Medicine Initiative. And as Dr. Levine and Chancellor Gallagher had mentioned, this initiative will recruit 1 million people. It'll be the largest data set available for scientists. This will include data, including survey data from participants, electronic health record data, measurements, biosamples. People will be sequenced, omics will be run. People will be asked to engage in future studies. And when you have a database this large, you can do amazing things. You can develop new ways to risk stratify just about all kinds of diseases, identify new biological markers for disease. You can hopefully eliminate health disparities. You can figure out, are mobile technologies actually useful to improve health? And you could do targeted clinical trials, enroll people based on their genetics, rather than just randomizing them. So when RFA came out, they were looking for institutions to enroll patients into this 1 million-person cohort. And the first person who walked into my office was my finance director, Dave Mathias, who said, we must apply for this because we have all the pieces. Because over the last 10 years, we built the CTSI strategically. We knew something bigger was going to come along. We just didn't know what it was. And when this came along, Dave comes into my office and said, this is it. We had all of the pieces. If you think about it, we had the puzzle here. We had all of the CTSI cores. We have, special populations core, regulatory core, an innovation core, a community core, an informatics core. We work with UPMC, we're Pitt, we work with the health plan. When you put it all together, all we needed to do was tell a story. Just like those pictures I showed you earlier. We told a story. I'll tell you, that's the easiest grant we ever wrote. It's the fastest grant we ever wrote, and we got the top score in the United States. So we are now enrolling 150,000 people in this 1 million-person cohort. And like Dr. Levine mentioned, we are number 1. We have almost as many people as number 2 and 3 combined in the country, and we're moving ahead. But there's more, because we want to figure out what else can we do to help our scientists directly. So in addition to enrolling in a 1 million-person cohort, we're going to develop a Pitt UPMC biobank. So we're going to take these individuals and more, and up to 200,000 individuals. We're going to ask them to sign a Pitt consent, initially give saliva and then blood samples. We're going to bank these samples. We're going to extract DNA. We're going to run pharmacogenomics in a UPMC clinical CLIA certified lab. We're starting with pharmacogenomics because we want to learn how do you actually give genomics data back to patients and back to providers so they can make decisions based on this. So this is really the first time we're going to do this large scale here in Pittsburgh. We're going to have EHR data. The health plan is going to contribute claims data. We're going to contribute multiple millions of dollars in pilot funding so our investigators can use our biobank. My vision is everyone's vision nowadays. It's all about big data, right? So when we have our own biobank, we're going to have all these data. It's going to come down to machine learning. How do you get computers to learn to look at patterns? And a lot of people are doing this on campus, and we're going to do it a little differently because we're going to reach out to our friends, whether they're in the automotive industry and self-driving cars, whether they're in the aerospace industry. We want to learn how they approach machine learning, and we want to apply that to our work in the biomedical arena. And I'm going to start winding down here, and I'm going to show you a video that inspires me. This is a video that Wondros did to help us engage 150,000 people, because honestly, when I wrote the grant, it was easy. We're going to recruit 150,000 people, but that's a lot of people. So we needed Wondros' help. So you'll see this. A lot of the design thinking that they did came through in this video. So this is what the message we're trying to push out there.
See, we're Pennsylvania. We're the farmland. Towns and the cities. The home of constant innovation. From this land came a nation's independence, and from the same land will come a healthier future. Because what flows in our veins is more than just data. It's diversity, vision, life. All of us have the power to change the world, to embrace the differences inside of us that will lead to answers for generations to come. We're asking Pennsylvania to come forward and stand on this landmark in history, to help unlock the mysteries that bring forth breakthroughs, to do what our state does best: lead the way forward.
So does that inspire you? Does anyone want to be one in a million? I need 148,000 more people. I have a table in the back outside if you want to sign up. So please sign up. So I'm going to end here and show you my most favorite family picture, because I would like to thank my family. So many of you know Evelyn, who's in pediatrics here on faculty. This is John, and this is David. Now, this picture's 2 years old. Now, I heard some chuckle from my old friends who are sitting up here, because they know that the Reese family has absolutely no musical talent. I mean, I can't even hear a beat, which is ironic because I'm a cardiologist, right? But we were visiting my sister's house. My sister's family has all of the musical talent. And my niece and nephew, one holiday, decided they were going to teach us how to play instruments. So the reason why this is my favorite Reese picture is because it tells a story. And the story is that the Reese family is not afraid of taking on any challenge. We will take on any challenge, but the rule is we'll take on any challenge together, because our motto is family comes first. And finally, I want to thank my parents, Marcia and Stan Reese, who are here today, for all of the opportunities and support and advice and guidance and love over my lifetime. And I'm going to dedicate it to them, my most favorite cartoon from the New Yorker magazine. Everyone ready? Dad, now can I be a fireman? Thank you very much.